Good morning, Rafi. Good morning, Rafi. So in the previous class, discussed about properties of classical sets. Next one, types of numeric functions. Okay, and all those. So in that we discussed about various types of membership functions and their explanation, right? So here we have discussed only two membership functions. That is, one is a triangular membership function, and the second one is a trapezoidal membership. In total, we have six. Okay, in total we have six membership functions. So we discussed only two. We discuss the remaining two. Okay? So coming to the types of membership functions, and there are six types of membership functions. They are trapezoidal, triangular, trapezoidal, Gaussian, all those. Right? Now let me share the screen to you. So these are the membership functions. One is a triangular membership function. Next one, trapezoidal membership function. Next one, Gaussian membership function. Next one, generalized Bell membership function. Next one, sigmoid membership function. So these are the six types of membership functions. Right? So come to the first one, that is triangular membership function. So this is the formula for triangular membership function. So it has three parameters, A, B, C, which are defined as follows. Right? The triangle of x ABC equals to 0, where x less than or equals to a. Next, when a is less than or equals to x than or equals to b, then we get x minus a by b minus a. Next, c minus x by c minus b, where b less than or equals to x less than or equal to c, and next 0 when c less than or equals to x. Okay, so this is the formula for triangular membership function. Right? Next, by using the min and max values, the min and max values are defined as follows. So we have a lateral expression for the preceding equation. So by using the min and max, we can write the formula like this. So triangle of x ABC equals to max of min of x minus a by b minus a, comma c minus x by c minus b, comma 0. Okay, so this the range is from okay. So the parameters A, B, C with A less than B less than C. Then we have to determine the x coordinates of three corners of the underlying triangle membership function. So this is how to draw the triangle membership function. Okay. So it is defined by the triangle x 20, 60, and 80. So A is 20, B is 60, and C is 80. Okay. Now we can draw the membership function like this. Okay. So this is how to draw the triangle membership function. Right. Next one is trapezoidal membership function. So this is the formula for trapezoidal membership function. So this is defined with four parameters. This is defined with the four parameters A, B, C, D. Okay. So now we can define trapezoid of x A, B, C, D equals to 0 when x less than or equals to a. Next, x minus a by b minus a when a less than or equals to x less than or equals to b. Next equals to 1 when b less than or equals to x less than or equals to c. Next, d minus x by d minus c, where c less than or equals to x less than or equals to d. And 0, where d less than or equals to x. Okay, so this is the formula for trapezoidal membership function. And next, by using min and max, we can define the above formula as trapezoid of x abc equals to max of min of x minus a by b minus a, comma 1, comma d minus x by d minus a, comma 0. Okay. So here we have four parameters, that is a, b, c, d, with a less than b less than or equals to c less than d. We have determined the x coordinates of the four corners of the underlying trapezoidal membership function. So by the below figure, we can define the trapezoidal membership function like this. Okay, you see this one. Here the ABCD values are x 10, 20, 60, 95. A equals to 10, B equals to 20, C equals to 60, and D equals to 95. Okay. Now we can draw the graph like this. Okay. Next. So the trapezoidal membership function. So here you have to remember one thing. So one is there is the trapezoidal membership function with parameters a, b, c, d reduces to a triangular membership function also when b is equal to c. Okay. So the condition here is, here this one. So the condition here is this one. A less than b less than or equals to c less than d. Okay. And this is the case. You'll get this one. Okay. This try. You'll get the graph like this. Right? So when A less than B less than is equals to C less than D, then we're going to get this one. Okay. Okay. So when B is equal to C. So when B is less than C, when B is less than C, then we're going to get this one. Okay. Okay. Otherwise, when B is equal to C, then we're going to get the triangular one. Okay. Okay. So then we are going to get the triangular membership function. So when B is less than C, we'll get this one. Otherwise, when B equal to C, then we're going to get triangular membership function. Okay, that's it, right? As the above two, there is a triangular membership function and trapezoidal membership function. As they are simple, as they have simple formulas and computational efficiency is simple. So they are extensively and especially used in real-time implementations. So in real-time implementation and also extensive use because of their because as they're simple, because of their simplicity, because of the simplicity in trapezoidal and triangular membership functions, they're extensively used in real-time applications. Okay? Right. So, however, since the membership functions are composed of straight line segments, they're not smooth at the corner points specified as the parameters. That means, so one disadvantage with this one is, as they are straight line segments, they are not smooth at the corner points specified by the parameters. So, because of that thing, I'm going to use the remaining membership functions. That is Gaussian, generalized Bell membership, next ones, and sigmoid, and others. Right. Okay. So see this one. Next one is Gaussian membership function. So come to Gaussian membership function, which is specified by two parameters. It is specified by two parameters, that is C and sigma. It is specified by two parameters, C and sigma. Okay, so definition is like this. So Gaussian of x, C comma sigma equals to e power minus 1 by 2 to the power of x minus c by sigma whole square. So this is the formula for Gaussian membership function. Okay. So uh, in this we have two parameters, that is C and sigma, where C represents the membership function center, C is the center, and sigma determines the membership width. Okay, width is defined by sigma, and center is defined by C. Okay, C means center, and sigma means width. Okay, next. So the following figure plots a Gaussian membership function defined by Gaussian of x, where C equals to 50 and sigma equals to 20. So we're going to draw the graph like this. Okay. So C is the center. Center means between 40 to 50, you have 50, right? That's why I had run this here. Okay, 50. Means 50. C is the center. The center means this one, this position. Okay. Right. So that's why I have taken 50. And next one is 20. That is sigma value. Okay. This one. Next one. Next one is generalized membership function. So this one is another name for this one is bell-shaped function. Okay? Generalized membership function or bell-shaped function is specified by three parameters A, B, C. Okay, is defined as bell of x A, B, C equals to 1 by 1 plus x minus c by a mod of 2 power b, mod of power 2b. Okay, x minus c, mod of x minus c by a to the power of 2b. Right. So here the parameter b is usually positive. B is positive here, and there is also a possibility of b becoming negative. Okay, so b is negative. The shape of the membership function will become upside down bell. Yeah. Okay, so this particular membership function is a direct generalization of Cauchy distribution used in probability theory. So it's also referred to as Cauchy membership. Next, because of their smoothness and concise notation, Gaussian and Bell membership functions are becoming increasingly popular for specifying fuzzy sets. Okay, so uh, this particular Gaussian and Bell membership functions are extensively used in fuzzy sets. Okay, in fuzzy sets. So Gaussian functions are well known in probability and statistics. So uh, these are this particular Gaussian membership functions are used in probability and statistics. Okay, so they possess useful properties such as invariance under multiplication. Okay, invariance under multiplication means the product of two Gaussians is a Gaussian with a scaling factor, right? And Fourier transform. So they are used in invariance under multiplication and Fourier transform. Okay, Fourier transform means the Fourier transform of a Gaussian is still a Gaussian. Okay, so when you do Fourier transformation, you're going to get a Gaussian function. Okay, next. So the Bell membership function has one more parameter than the Gaussian membership function. So it has one more degree of freedom to adjust the steepness with the crossover points. So these two, that is Bell membership functions and Gaussian functions, have smoothness when compared to the previous two, that is triangular and trapezoidal. This is smooth, and and they are unable to specify the asymmetric membership functions that are important in certain applications. Next, come to the next one, sigmoid membership function. Sigmoid membership function. So a sigmoid membership function has two parameters. Okay, two membership functions, A and C. Okay, A and C, two parameters A and C, where A is responsible for slope at the crossover point, x equals to C. The membership function of sigmoid function can be represented as sig mf, sig mf of x a comma c, and it is defined as sig mf of x abc equals to x ac. Sigmoid function sig mf of x a comma c equals to, not abc, a comma c equals to 1 by e plus 1 by 1 plus e power minus a of x minus c. Okay, so this is how to draw the sigma membership function. So this particular sigma membership function is inherently open right or left, and thus it is appropriate for representing concepts such as very large or very negative. Okay, open right means very large, open left means very negative. Okay, next, this particular function is mostly used as activation function of artificial neural networks, that is ANN. It is used in ANN, that is artificial neural networks. Okay, so this particular ANN uses this particular sigmoid function to simulate the behavior of fuzzy inference system. Okay. So this is regarding the types of membership functions, right? So next topic is types of fuzzy propositions. Types of fuzzy propositions. So coming to the types of fuzzy propositions, the types are here. First one, unconditional and unqualified proposition. Next one, unconditional and qualified proposition. Next one, conditional and unqualified proposition. And next one is conditional and qualified propositions. So these are the four types of fuzzy propositions. The first one is unconditional and unqualified proposition. Okay, so the canonical form of this type of fuzzy proposition is P colon V is F. Okay, where V is a variable which takes value V from a universal set U. F is a fuzzy set on U that represents a given inaccurate predicate such as fast, low, tall, etc. Okay, for example, P, speed of V is high F. Okay, then T of P equals to 0.8 if P is partly true. And next, if T of P equals to 1 if P is absolutely true. Next, T of P equals to 0 if P is totally false. Okay, so this is nothing but unqualified and unconditional proposition. Okay. Right, next one. So where T of P equals to mu of f of V. T of P equals to mu f of V, membership grade function, which indicates that the degree of truth of V belongs to F if its value ranges from 0 to 1. Okay. And next one is unconditional and qualified proposition. Okay, so this particular proposition is defined like this. The fuzzy proposition is P colon V is F is S, where V and F have the same meaning and S is a fuzzy truth qualifier. S is a fuzzy truth qualifier and V and F have the same meaning. For example, P speed is high is very true. That is unconditional and qualified proposition. Next one is conditional and unqualified proposition. Conditional and unqualified. So this particular fuzzy proposition is defined like this: P colon, if x is A, then y is B, where x and y are variables in universes U1 and U2, and A and B are fuzzy sets on x and y. For example, P, if speed is high, then risk is low. That is conditional and unqualified proposition. Next one is conditional and qualified proposition. So the canonical form of this type of fuzzy proposition is P colon, if x is A, then y is B. If x is A, then y is B is S. So where all the variables have same meaning as previous declared. For example, P, if speed is high, then risk is low. If speed is high, then risk is low is true. Okay, that is conditional and qualified proposition. Okay, so this is regarding types of fuzzy propositions. Total four types: unconditional and unqualified proposition. Next one, unconditional and qualified proposition. Next one, conditional and unqualified proposition. And next one, conditional and qualified proposition. So these are the four types of fuzzy propositions. Okay. Okay. So now we'll see some more topics here. Let me share my screen here. Why is Sapat lefting? Why is not leaving the class? 3 have left. That is not over, no? Now let us see some more topics here. There is fuzzy logic, right? Okay. So this particular fuzzy logic is a method of reasoning. So fuzzy logic is a method of reasoning that resembles human reasoning. That means, for example, a human being has done something. Okay, when you ask him why you have done like this, then he's going to tell some reason. So the same way, fuzzy logic is also a method. It is a method of reasoning that resembles human reasoning. That means how a particular human being reasons for something or gives reason for something. This part of fuzzy logic also does like this. Okay, means it's a method of reasoning. That means it will tell why this particular thing has been happened. Okay, so it resembles the human reasoning method, right? So fuzzy logic is a method of reasoning that is same as human reasoning or that resembles human reasoning. Okay, right. So the approach of fuzzy logic imitates the way of decision making in humans that involves all intermediate possibilities between digital values S and no. Okay, that means so it is going to tell us yes or no answer. So it is going to tell the answer as yes or no. Okay, so the digital value yes or no is the thing we are going to get. Okay, so this particular that is how a particular human being takes decision while doing something. This a particular human being is wants to do something. Okay, then he's going to take decision whether this is to be done or that is to be done. Okay, so in the same way, fuzzy logic is also uh, imitates the way of decision making in humans. అంటే మామూలుగా మనుషులు ఏ విధంగా అయితే డెసిషన్ తీసుకుంటారో అంటే అది చేయాలా చేయకూడదా అనేది ఎలా డెసిషన్ తీసుకుంటారో ఈ ఫజీ లాజిక్ కూడా అలాగే డెసిషన్ తీసుకుంటారు. సో ఇట్ ఈస్ ద వే ఆఫ్ డెసిషన్ మేకింగ్ ఇన్ హ్యూమన్స్ దట్ ఇన్వాల్వ్స్ all intermediate possibilities between digital values S and no. Okay? The conventional logic block that a computer can understand takes precise input and produces a definite output as true or false. So that means it is going to give the output as true or false, which is equal to humans yes or no. అనేది మన ప్రకారం అంటే హ్యూమన్ బీయింగ్ ప్రకారం ఎస్ అంటే దాని యొక్క వాల్యూ ట్రూ, నో అంటే దాని యొక్క వాల్యూ ఫాల్స్. ఓకే ఓకే సో మనకైతే ఎస్ ఆర్ నో అంటాం, అది సిస్టమ్ అయితే ట్రూ ఆర్ ఫాల్స్. ట్రూ అంటే 1, ఫాల్స్ అంటే 0. ఓకే దట్ ఈస్ డిజిటల్ వాల్యూ. Digital values 0 and 1. 0 means false, true means 1. Okay. So the inventor of fuzzy logic is Lofty Jade. So Lofty Jade is the inventor of fuzzy logic. So he observed that unlike computers, the human decision making includes a range of possibilities between yes and no. Okay, that means this one. See this one. Certainly yes, possibly yes, cannot say, possibly no, certainly no. So these are some of the yes and no values. Okay, అంటే ఏంటి అవ్వచ్చు అవ్వకపోవచ్చు అట్లా. ఓకే సర్టన్లీ ఎస్ అని ఖచ్చితంగా అవుతుంది, పాసిబిలీ ఎస్ అవుతుంది, కెనాట్ సే చెప్పలేము, పాసిబిలీ నో అంటే అవ్వచ్చు అంటే అవ్వకపోవచ్చు, పాసిబిలీ నో మీన్స్ అవ్వకపోవచ్చు, సర్టన్లీ నో మీన్స్ అవ్వదు, ఇట్లా ఉంటుంది. ఓకే సో దీస్ ఆర్ సమ్ ఆఫ్ ద possibilities. So the range of possibilities between yes and no. Okay, these are some of the possibilities. Okay, ఏంటి సో హ్యూమన్ ఓకే సో అంటే కంప్యూటర్స్కి అయితే ఓన్లీ జస్ట్ ట్రూ ఆర్ ఫాల్స్ అని చెప్తాం, కానీ అది హ్యూమన్ బీయింగ్ అయితే ఇలా చెప్పే ఛాన్సెస్ అంటే సర్టన్లీ ఎస్, పాసిబిలీ ఎస్, కెనాట్ సే, పాసిబిలీ నో, సర్టన్లీ నో, ఇలాగా అంటే హ్యూమన్ బీయింగ్ అయితే ఇలా ఆన్సర్ చెప్తారు. ఆ సిస్టమ్ అయితే ఓన్లీ ఎస్ అయితే ఎస్, నో అయితే నో, అంటే అలాగా ట్రూ ఆర్ ఫాల్స్ అంతే, ఓన్లీ 2 థింగ్స్. Right. So coming to the implementation of fuzzy logic, it can be implemented in systems with various sizes and capabilities, ranging from small microcontrollers to large microcontrollers. Next, networked networker systems, workstation-based control systems, all this. Okay, so it can be implemented in hardware, software, or a combination of both hardware and software. Okay. Now, why to use fuzzy logic? Why to use fuzzy logic? So fuzzy logic is useful for commercial and practical purposes. It can control machines and consumer products. So next, it may not give accurate reasoning, but it will give acceptable reasoning. Next one, fuzzy logic helps in dealing with the uncertainty in engineering. So these are some of the reasons why we have to use fuzzy logic. Okay. Okay. So this is regarding today's class. I'll discuss the remaining topics in the next class. Okay. Thank you. And next, one more thing. Some of you have not submitted your assignments. For those who want to submit your assignments, today is the last date. Okay. Um, in today's chat box, I have given you my mail ID. So those who have not submitted your assignment, please submit your assignment to that mail ID, which I have given in today's chat box. సో జూమ్లో చాట్ బాక్స్ ఉంది కదా, ఆ చాట్ బాక్స్లో నేను నా మెయిల్ ఐడి పెట్టాను. ఆ మెయిల్ ఐడికి మీ అసైన్మెంట్స్ ఫార్వర్డ్ చేయండి. సో as today is the last date. సో ఇవాళ లాస్ట్ డేట్. ఓకేనా. సో బి సెక్షన్ అండ్ సి సెక్షన్ సిఆర్స్ ఒకసారి చూడండి అమ్మా, ఎవరెవరు సబ్మిట్ చేయలేదో వాళ్ళు దీన్ని సబ్మిట్ చేయమని గ్రూప్లో పెట్టండి. ఓకేనా. ఎందుకంటే ఇవాళే లాస్ట్ డేట్. బి సెక్షన్ అండ్ సి సెక్షన్ సిఆర్స్ ఒకసారి అందరికీ ఇన్ఫార్మ్ చేయండి. ఈరోజు సాయంత్రం లోపు సబ్మిట్స్ అన్నీ వచ్చేయాలి. సబ్మిట్ చేయని వాడికి నేను చాట్ బాక్స్లో పెట్టిన మెయిల్ ఐడికి ఎస్ఎంఎస్ పంపించమని చెప్పండి. థ్యాంక్ యూ.